Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the composition of functions or function composition. Feel free to pause the video at any time, rewind if necessary if you would like to hear a concept explained again. This lesson will work best if you follow along and try the problems with me. There are some problems that I'll pause and have you try it on your own, and then we'll check your answer. So in example 1, it says, suppose you work 40 hours a week at a furniture store. You receive a $550 weekly salary plus 3% commission on sales over $5,000. So in other words, you only get commission when you sell over $5,000. So let's say last week you only sold $4,000 in sales, then you would only receive your weekly salary. So you only get commission if you sell over $5,000. To calculate your pay in this situation, you would need two functions. The first function we'll call f of x. It's 550 plus 0.03x, where x represents the sales over 5,000. Then we have our second function, g of x is equal to x minus 5,000, where x represents the total sales. So in part A, it said, if you had $8,000 in sales last week, what would your pay be? So the first thing we're going to do is we're going to take this $8,000 and we're going to input it into our first function, which is g of x. So g of x was the function x minus 5,000. So if my input or my x value is 8,000, well, 8,000 minus 5,000, we would get, for our output, we would get $3,000. So this was your input, this was your output, okay? The 3,000 was your output. Now what we're going to do, now that we know the amount over 5,000, this new number is going to be our new input, and it's going to be plugged into our second function. F of x equals 550 plus 0.03x. Now, I have the calculations over here on my calculator. 550 plus 0.03 times 3,000 gives me a total pay of $640. So, in the example above, it's a real-world example of function composition. The output of the first function, that was this number right here, became the input of the second function. In function composition, we combine the two functions so that we can skip the middle step shown above. Now let's look at a definition. The composition of functions is the process of combining two or more functions into a single function by making the output of one function the input of the other function. Mathematically speaking, the output or range of one function becomes the input or domain of the next function. Now, the notation for function composition is a little weird looking. And when you look at it, you see this f and then a little circle and then a g and then parenthesis of x. That's one way to write that. And then the other way that we write it looks like this, f parenthesis g of x. I prefer the second way. You'll probably see me using this way the most. But the way we read either one of these is f of g of x. Okay, now we could also turn it around. We could have g of f of x, which is the same thing as g of f of x. Again, I much prefer the second way. That's the way you're mostly going to see me using the notation, but you need to be familiar with both ways. So in example 2, it says, if f of x is equal to x squared minus 3 and g of x equals 3x plus 2, find each of the following. So in problem A, they're asking us to find f of g of 1. So this is called our function composition notation. And when you're working with function composition, you always start on the inside of the parentheses and you evaluate that part. Then you move to the outside of the parentheses. So we're going to first calculate g of 1. Now, the g of x function is 3x plus 2. So I'm going to put, instead of x, I'll put 3 parentheses plus 2, and then I'll plug in the number they gave me. They want us to evaluate g at x equals 1. So I'm going to put a 1 right there for x. So 3 times 1 is 3. 3 plus 2 is 5. So g of 1 is equal to 5. Now you work on the outside of the function. So the function on the outside of the parenthesis is our f function. So we'll take this output and make it our new input. So this time we're going to find f of 5. So this number goes in here. So our f function is x squared minus 3. So I'm going to put parentheses squared minus 3, because that's my f of x function, x squared minus 3, and I will plug in the 5 and evaluate that. So 5 squared is 25. 25 minus 3 is 22. Now go back to the very beginning of the problem. F of g of 1 would be 22. All right, let's look at another example. We're asked to find in problem B, g of f of 2. So remember, always start on the inside of the parenthesis. So they're asking us to calculate f of 2. Now our f function is x squared minus 3. So parentheses squared minus 3, and we're plugging in a 2. So 2 squared is 4, and 4 minus 3 is 1. Now remember, that number, that's our output. That's going to become the input of the second function. So you ask yourself, what letter is on the outside of the parenthesis? Well, in this case, it's a G. So we are calculating now G of 1. G of 1. So the g of x function was 3x, so 3 parentheses, plus 2. And now I'm going to plug in a 1. So 3 times 1 is 3. 3 plus 2 is 5. So back to the beginning. G of f of 2 is equal to 5. All right, problem C. G of 0. So again, starting on the inside first, we are going to calculate g of 0. So our g of x function is 3x plus 2. So I'm going to put 3 parentheses plus 2, and I'll plug in a 0. Now when I evaluate that, 3 times 0 is 0. 0 plus 2 is 2. Now we're going to look on the outside of the parenthesis. That is also g. So now I'm calculating g of 2. So whatever you get here always becomes the new input. So 3 parentheses plus 2, plug in a 2. So that would be 3 times 2 is 6. 6 plus 2 is 8. So g of 0 is equal to 8. All right. Problem D. Now, problem D is written in the notation that I do not care for. F, they're wanting us to calculate f of g of negative 2. So if you don't mind, I'm going to rewrite this like in the notation that I'm more familiar with. F of g of negative 2. And then from there, it's just like the problems above. you work on the inside first. So you're going to calculate g of negative 2. G of negative 2. Now the g function, g of x, is 3x plus 2. So this would be 3 parenthesis plus 2, plugging in negative 2. So 3 times negative 2 is negative 6. Negative 6 plus 2 would be negative 4. Okay, now you're going to look on the letter on the outside of the parenthesis, which is f. So now you're calculating f of negative 4. Now the f function is x squared minus 3. So parentheses squared minus 3, and I'm going to plug in a negative 4. So negative 4 squared is 16. 16 minus 3 is 13. So f of g of negative 2 is equal to 13. Let's try another one of those. In problem E, we have g of f of 3. So I'm going to rewrite it in this notation. This is what we're trying to find. G of f of 3. So again, start with the inside and work from there. All right, I'm going to let you pause the video and try the rest of the problem on your own. All right, welcome back. Hopefully you calculated f of 3 first and got 3 squared, which is 9, 9 minus 3, which is 6. So hopefully you did that part right. Okay. Then that output became your new input. So the letter on the outside here was G. So I am calculating G of 6. And that's going to be 3 parenthesis plus 2, plug in a 6. 3 times 6, 18. 18 plus 2 gives me 20. So check your answer on that problem. G of f of 3 was equal to 20. All right, pause the video and try problem F on your own. All right, welcome back. The first thing I did is I rewrote this as f of negative 1. And then I calculated f of negative 1 to be, let's see, that function was parentheses squared minus 3. I plugged in a negative 1, and I got negative 1 squared is 1. 1 minus 3 is negative 2. This is a place where a lot of students make errors, because if you put negative 1 squared in your calculator, you're going to get the answer wrong. Remember, put negative 1 in parentheses. Okay, so negative 1 squared is positive 1. All right. Now I'm going to calculate f of negative 2. So negative 2 squared is positive 4, and positive 4 minus 3 is 1. So f of negative 1 is 1. Just so you'll know how I put it in my calculator, we say negative 2 in parentheses squared. The parentheses are important there, minus 3. Okay, positive 1. So f of negative 1 was equal to 1. If necessary, pause the video and correct anything that you got wrong on problem E or F before you move on to the rest of the notes. All right, moving on. In problem example 3, it says f of x is the function 3x minus 1, and g of x is the function 2x plus 5. Find each of the following. So in problem A, they want us to find f of g of x. Now I'm going to rewrite it in this notation, f of g of x. Now what's different in this problem is they didn't give us a numerical value. Okay, so when there's not a numerical value, what you're going to do is you're going to look at the letter on the outside of the parentheses, which is f. And that means we're going to write the f function down, which is 3x minus 1. Then you're going to replace the x with parentheses. And then you're going to look back at your original problem. Look what's inside the parentheses. So g of x is going inside the parenthesis here. So we're going to plug in 2x plus 5. Now from here, you're just going to simplify this. Distribute the 3. So 3 times 2x would be 6x. 3 times 5 is 15. And then we have our minus 1. Combine like terms to get 6x. 15 minus 1 is 14. So f of g of x would be 6x plus 14. All right. Problem B. We are finding g of f of x. So on this problem, it's the g that's on the outside of the parentheses. So we're going to write down the g function, which is 2x plus 5. Then replace the x with parentheses. And then you're going to look back at your original problem. And this will tell you what to plug into the parentheses. It says to plug in f of x into the parentheses. So when I plug in f of x, that was 3x minus 1. Now we're going to simplify this here. We'll distribute the 2, so this would be 6x minus 2 plus 5. Combine like terms to get 6x plus 3. So g of f of x was equal to 6x plus 3. All right, example 4. If f of x is 2x plus 5, g of x is x squared minus 3, and h of x equals negative 4, find each of the following. So in problem A, they want us to calculate f of g of x. All right, so I want to look on the outside of my parenthesis, and we see the letter f. So I will write down the function for f, which is 2x plus 5. Then I will replace the x with parentheses. And if you'll look back at the original problem, it tells you what to plug into the parentheses. It says to plug in the function g of x, which in this problem, g of x is equal to x squared minus 3. So that goes right here. Now you just simplify that. All right, so 2 times x squared is 2x squared. 2 times negative 3 is negative 6, and then plus 5. So 2x squared, and then negative 6 plus 5 would be negative 1. So f of g of x is equal to 2x squared minus 1. All right, pause the video and try problem B on your own. All right, for problem B, hopefully you wrote down the f function first, 2x plus 5, and then you replace the x with parentheses. And then it told us to plug in h of x. Now, according to our original problem, it said h of x is equal to negative 4. So that means I'm plugging in a negative 4 for x. Now, when I work that out, 2 times negative 4 is negative 8. And negative 8 plus 5 would give me negative 3. So f of h of x is simply equal to negative 3. Now, we can even use function composition when we don't know the function rules, but we do have a graph of the function. So in example 5, it says the graphs below are the functions y equals f of x and y equals g of x. Evaluate each of the following based on the graph. So remember, you're going to start inside the parentheses, and we're going to be calculating not f of x, excuse me. We're calculating f of 0. All right. Now, how do we calculate f of 0 on the graph? Well, this is your input or your x value. So this is saying when x is 0, what is y? When x is 0, what is y? So because we're working with the f of x function, we want to make sure we're looking at this graph, okay, that we highlighted in green. So if we want f of 0, this is x equals 0 here. Where does that, what is the function value right there? Okay, so this would be right here. Let me label it f of 0 equals 2, and that's this value right here. So I know f of 0 is 2, the y. The x value is 0, the y value is 2. All right, now that we've evaluated that, you're going to look on the outside of the function and notice it's a g. So that tells me I'm going to find g of 2. So this time I don't want to use the graph on the left. I want to use the graph on the right because it's my g function. So if my x value, again, that's your x value, 2. If my x value is 2, we want to know what is the y value. So on the graph, go to the right 2, 1, 2, and then up, 1, 2, 3, 4. So let me label this. G of 2 is equal to 4. That's this point right here. When x is 2, y is 4. So g of f of 0 is equal to 4. All right, let's look at our next problem. F of g of 2. So we want to start by calculating what's inside the parenthesis, which is g of 2. Always start with what's in the parentheses. Now, we already calculated g of 2. It's on our function up there. We've already labeled it. We know that g of 2 is equal to 4. Now, on the outside of our parentheses is f. So the next thing we do is calculate f of 4. So I'll go over to my graph, my f of x graph, and go 1, 2, 3, 4, and then up 1, 2, 3, 4. So that's right there. So we know that when x is 4 on this graph, the y is also equal to 4. So that's this point right here. So f of g of 2 is equal to 4. All right, problem C. F of 0. So again, we start out with the inside, and we're going to calculate f of 0. Now, we already calculated f of 0. It's already written down. We know that f of 0 is equal to 2. Okay. Now, notice that we also have another f on the outside of the parenthesis. So now I'm calculating f of 2. So I want to go back to the f of x function, but this time I'm just going to go to the right 2, and then 1, 2, 3. So let me label that. When x is 2, f of 2, our y value is 3. So f of 2 is equal to 3. So f of 0 is equal to 3. Final answer. And that concludes today's lesson, Composition of Functions.